All right, hello again, everybody. Now we're going to start talking about section 4.3. So this is going to be about something known as logarithmic functions. So what is a logarithm? So a logarithm is where you can write something in, you've still got a base, a power, and then a number it equals. But the idea of a logarithm is it's like a tool that can be used to find a missing exponent that you don't know. And so the first thing we need to get a handle on is just what a logarithm is. So if I have the statement b to the y equals x, that's probably something you're more accustomed to. The way you would write that is y equals the log of base b, and then x is what goes into this new function called a logarithm. If that's a little abstract, let me put some numbers in there to maybe help you all make sense of this. So for instance, I could have something like this. 9 squared is equal to the number 81. I trust that's not a terribly controversial statement. Now, this is exponential form because it's written with an exponent. If I want to convey this same idea, but do it in logarithmic form, then what logarithmic form would look like is this. So the base of the power, the big thing on the bottom, like if you think of a base is something that's big that holds things up, right? That's what a base is. So the base of the power is also known as the base of the log. So what I would do is I would call this log of base 9, because that's the base of the power. The number that goes into the logarithm is what that equals, which is 81. And then what the logarithm equals, the log equals an exponent. So the exponent that you need to go from 9 up to 81 is an exponent of 2. This is known as logarithmic form. And the big thing to know, a log equals a power. What a logarithm will equal is a power. It will be a power that you need to go from the base up to the number that you put into it. So they say, write the following logarithmic equations in exponential form. So here we just have a statement and we're just switching it from one form to another. That's all that this entails. So if we start with part A here, the base for A is a 6. The power is the thing that the log equals, which is 1/2. And then what's inside is what you would normally get from doing the exponents. So this is telling us 6 to the 1/2 power is equivalent to the square root of 6. That is the solution. And fun fact, the 1/2 power is equivalent to the square root. If you were not yet aware of that fact, that is a thing. You can actually write any root as a power and it'll involve a fraction. 1/2 power is equivalent to a square root. Let's look at part B. So the base, that's the little bitty number on the bottom of the log, that is a 3. What the log equals is the power, that's a 2. And then what goes inside is what the power will equal. So that basically means 3 squared equals 9, which is probably something you're more accustomed to, but the log version of that statement is log base 3 of 9 equals 2. That's this kind of newfangled thing. And at the moment, it may kind of be like, well, so what? What's the big deal? Well, so the idea is that if you want to find an exponent to try to predict at some point in the future, like when you're going to hit a certain amount. That's why logarithms are a big deal, because they can help with trying to predict and find the power that you need to reach a target number. If you think of the money problems we were doing earlier, instead of just saying, here's some money, here's an interest rate, and we're going to do it for like 30 years, you can instead have the question, my goal is to make $4 million. How much time is it going to take me to do that? And so you have like a target in mind, and you would find the power that you would need to reach that number. All right. Write the following logarithmic equations in exponential form. Okay, so this shouldn't be too bad for us here. So we've got 10 is the base. The power is going to be the 6 that it's equal to. And then that should equal the number that's inside, which is 1 million. And fun fact, a power of 6 is going to be a 1 with 6 zeros, for fun fact. Part B, the base is 5. That's the base of the logarithm. 2, what it equals out here, that's going to be the power. And then this is going to be equivalent to what you put into the logarithm. And that gives you the statement that I imagine you've encountered before, that 5 squared equals 25. How about that? So that's how you can kind of go back and forth between log form and exponential form. That's all that we're doing here. We're just sort of rearranging what goes where. Here, we're doing the same idea. We're just doing it backwards. So this time they start in exponential form, and our goal is to rewrite them in log form. So let's start with part A. You have 2 to the 3rd power equals 8. The base is a 2. So we're going to write that as log of base 2. The 8 is what goes inside of the log. So the 8 comes over to the left side where the 2 is. And then the 3 that was the power is going to move over to the other side on the right. And so the equivalent version of that statement is saying log base 2 of 8 equals 3. For part B, 5 squared equals 25. So the base of the power is a 5. So we're going to call this log base 5. 25 is going to go inside the log, and then the power is actually what it equals. So then you switch that around, you end up with log base 5 of 25, and that now equals 2. Finally, we'll put this one over here. 10 to the negative 4 equals 1 over 10,000. So this is log base 10. The number that's over here comes over to the other side, 1 over 10,000. And then what the log equals is a power. It equals negative 4. And actually, we're not quite done yet. There's one more thing I want to say. There is something known as the common log. And that's just log of base 10 of x is written as just log 10, or I'm sorry, log x. So if the base is 10, usually a mathematician wouldn't bother to write that in, because log of base 10 is equivalent to just log. So this is log 1 over 10,000, and that equals negative 4. That would be what's considered the best answer, because log base 10 is usually just written as just plain old log for short. By the way, if you get your friendly neighborhood calculator right here, you will notice right next to that LN button we were using earlier, there is a log button right there. And that is for the common log. So what we could do is we could do log of 1 divided by 10,000. We could even work this out ourselves. You could do log of 1 divided by 10,000. And lo and behold, that gives you -4, which is what it's supposed to be. But so the calculator can evaluate common logs. The log button does anything with log base 10. Now, it doesn't have the ability to do logs of any base. It can't do log base 3 or log base 5 or whatever. But there is a way around that we'll get to later, and that's why the calculator manufacturers can get away with only giving you like one option for a logarithm, technically two, but we haven't gotten there yet. But there's a reason why they can actually kind of get away with that, because I'll show you later how you can evaluate a log of any base that you want. But more on that later. So that is the common log, which is written as just plain old log. What is this? Write these in logarithmic form. So this is just more practice with what we have been doing here. So you've got 3 squared equals 9. You can write that as log of base 3, the base of the power. 9 comes over here, 2 goes over there, and there you have it. That is the log statement of that equation. The next one, 5 to the third equals 125. Well, the base is 5, so we're going to do log base 5. We're going to put 125 now on the left with the log, and then what it equals is the power, which is 3. Finally, for part C, we have 2 to the -1 equals a half. So we're going to call that log of base 2, because that's the base of the power. 1/2 is going to go in here, and that is equal to -1. So this stuff should be kind of easy. It's just getting used to and acquainted with how to sort of reorganize a log statement versus an exponential statement, and knowing what goes where in the different forms. Excuse me. So I kind of mentioned this already. So log base 10 is also just written as log. And again, this is known as the common logarithm. And so this is the situation where you have y equals log x, that's equivalent to 10 to the y equals x. Incidentally, if you look on a calculator, the reason why the second function is 10 to the x power, it's because that's the inverse, that's the opposite of what the logarithm does. And that's why those two are together. Find the value of a common logarithm using a calculator. So this is a lot like the other one. All you need to know how to do for this is just know how to evaluate it correctly on the calculator. This should be easy points for everybody on the exam. No one should get this question wrong. Know where the log key is on the calculator you're using. Know how to find it. So it's the log of 321. Blink and you'll miss it. So here's the TI-84 on the, what is that, left-hand side. There's the log key right there. You push log, there it is. They wanted the log of 321. Go ahead and close the parentheses. It's a good habit to be in. You notice they give you an open parentheses. It's good to put a close parentheses on these all the time, just to be in that habit. And so it turns out that that's 2.5065, it looks like. So there you go. You say round to 4 decimal places, okay? So that means y is approximately 5.5065. And this is the kind of question where when I give you a test question, I will tell you as directly as possible, like, this is how many decimal places I'm expecting. All right, there you go, 5.5065. There's something else known as the natural logarithm. You make me feel like a natural law. Anyway, I don't know why that was I'm very sorry. That was unnecessary. But anyway, where were we? So that is log base E. That's what the natural log is. It's a logarithm of base E. So log base E, they write that as ln. Now, if it bothers you, like, why is it natural log? Like, why don't they do NL instead of ln? Well, this guy Euler that we mentioned earlier, who was Swiss, he spoke French. And in French, you wouldn't say the natural log, you would say the log naturel, because you put the adjectives after the nouns in French and other languages like it. So that's why it's ln, and it's also kind of consistent with like just log because they both start with L. But anyway, so it's the log of base E is what that is. And so for this example, which is down here, again, when you have a test question like this, there's no reason why anyone should get this one wrong. They want 4 decimal places here. And this should look familiar because, and this is partly why e to the power that we were using earlier, this is partly why it lives on the calculator with the ln key, because e to a power is the opposite, it's the inverse of the natural logarithm right there. So there's the ln key right there, right next to the log. So we're going to do ln, and I forgot, I've been jabbering so much, I've forgotten what number we're using. 500 is what it is. All right, so we're going to do ln of 500. So there you go. And go ahead and close your parentheses while you're at it. ln 500, there it is. And you do ln 500, they want 4 decimal places, 6.2146. So, all right, there you go. So this is 6.2146. 6.2146. There you go. And fun fact, if you do E and raise it to that decimal power, you will get a number that is roughly equal to 500. So like if you do E and do E to the 6.2146 power, that is approximately equal to 499.9959. 996. So it's a number really, really close to 500. So there you go. All right. That is the end of that section, and it is 8 o'clock. So let's take ourselves a 15-minute break, and we will start up again at 8:15. I will see you all in 15 minutes.